Hello YouTube, it's Philip20 again today, and I got some comments I got questions for everybody and a comment for everybody. Why should you go from a 12 volt system to a 48 volt system right off the bat? I'll give you an explanation. This inverter uses about 200 watts. It says it's about 145. It's actually pulling about 200 watts when it's in its battery power and 24 volts. And for the same amount of power from a 6,000 watt, same power output, low frequency inverter from Ames, I can get about 80 watts instead of 200. That's a big difference. This it's when if you're using 12 volts, it's about 400 watts just to be on for 6,000 watt inverter. That is power consumption continuous. That's, you plug in your kilowatt meter and you see your kilowatts. Well, that's how much power I'm using. No, you're powering the inverter too. You got to remember, you're powering your inverter, so it's consuming power just by being on. Right now it's off. I ran the battery too low last night, and I got nothing for sunshine. Right now I'm making about 751 watts, but in comparison, I can't run my house right now. These batteries are near dead. They're at 25.3 volts, and it's charging like crazy, and there's nothing being consumed off of it. But I need to switch to a 48 volt system. Now, I want you to understand that switching from a 24 volt system to a 48 volt system is relatively easy for the way I set it up. I didn't intentionally set it up this way. It's just the components that I purchased, like this system here. This right here, it's it does 12 volt, 24 volt, 60 volt, etc. So, and then everything in here is totally compatible with it. Everything's in conduit, so it's completely safe. All my breakers are 150 volts, and if you can see right here, I'm currently running at 82 volts coming into the charge controller. So, I mean, right now I'm making 730 watts or so, and it's like rainy, overcast. This will probably be, it's like 10 o'clock, a little bit after 10, I think. Yeah, 10:30 in the morning. It's super overcast, pretty bad for generating enough solar to run the house. Yes, I am, but I'm not. I'm generating enough solar to turn on this inverter, which is 200 of that power, 200 watts of my solar already. And it's more efficient than a 12 volt system. So it's 200 watts of that power is going straight to turn that on. So that leaves me with 533 watts that I can use. Now, granted, after I start consuming electricity, it actually takes more than 200 watts for the inverter to convert. So if I use 50 watts of alternating current, is consuming like 70 watts, 60 watts. You see what I'm saying? It's not a 1-to-1 ratio. The more power you consume, the more the inverter takes to transfer it over. And the harder it is if it's a lower voltage. So why am I going to a 48 volt system? Because I can't run this system continuously. It'll never happen. I'll never be able to run it on this battery bank or any other battery bank with 3,000 watts solar array. If I switch to 48 volts, that gets me a lot closer without buying a ton of batteries more. For a 24 volt system, for the power that I'm losing by inverting 24 volts. I'm going to switch to 48 volts. I'm probably going to switch to a lithium battery on that system. And I may even just leave this system in place. I might just build another battery bank and I haven't figured out how I would do if I could do that. I might have to build a whole new system if I did that, and I don't want to do that. But I've got all the conduit run, so it's not really that big of a deal. I mean, you see it right here. This is, one charge controller costs a fortune, and the solar array does. But a 48 volt system is much more efficient, and it'll do more for less energy. So instead of using like 60 watts, it might use 55 watts out of something that uses 50 watts. So also the inverters, you can stay on twice as long instead of, you cut it in half every, like if you had a 6,000 watt, you're going to be pulling about 400 watts out of a 6,000 watt inverter. That's 12 volts. Then it goes down to, it depends on the efficiency you get. This is a low frequency, and it's really clean power. It's really, really clean. It's got humongous transformers in it. If you haven't seen that, you can go take a look at some of the other videos I made. But it's really clean power, and you can get 48 volt low frequency inverters. But they use more electricity to make the cleaner power. And I'm fine with getting cleaner power. High frequency inverters is not something I want to get involved with. I have had some, and you'll hear a buzzing sound out of your electronics. I've noticed that with a pure sine wave, even that was an Ames, but right now it's not that big of a deal. What I'm trying to get at is, why would you want to go with a lower voltage system when it uses more power? I know that you can plug your car up to it and charge it, but your car can only output 50 amps at the most, unless you got an upgraded alternator. Then you might get 150 amp. But that's still irrelevant. If you ran 150 amps into something, you'd have to have really thick cables going to it at 12 volts. 150 times 12, divided by 150 amps. It's like 4-aught gauge wire for like 5 foot. And if you was to go with a 48 volt system, you can use teeny tiny wires, and you don't have to worry about the extra expense of buying really, really thick wire. And it's really hard to work with. It's no big deal. See, I bought these real thick, 4-aught wires right there. So, what's the difference? I could have half the size of that wire and still use have better current going into it. The higher the voltage is better. YouTube, tell me what you think about this. Tell me what your opinion is. What should you do versus what I did? So, thanks for checking me out. This is Philip 20 with Guns, Games, and Racing. And I'll holler at y'all later.